Properties of similar polygons is what we're going to be covering today. So there are some certain things you need to know about polygons. So let's go ahead and explain what similarity means. So similar polygons have the same shape, but not necessarily the same size. So it's either going to be smaller or larger than the other shape. So here I have two similar polygons, and I'm telling you that they're similar down here. This is called my similarity statement. And I have two pictures here, and they do look indeed similar to each other. This one is obviously bigger than this one, but as you can see, it looks to be about the same shape of the one over here, but it's much bigger, of course, than the one over here. And so I can take a look at my similarity statement, and my similarity statement tells me a lot of things. First of all, I see that A is the first letter to D, and so that means that angle A is congruent to angle D. Similarly, angle B is congruent to angle E, so I can put that in here. And angle C is congruent to angle F, so I can put that in here as well. So then I can go ahead and write the the congruent statements for all of these angles. And I can get all of that information just from looking at this. So this is my really important thing that I look at to help me know what is congruent to what and what is corresponding to what. Okay? So as you can see, I went ahead and said that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. So all the angles are equal to each other in similar polygons. Now something else that's true is that their corresponding sides are proportional. They're not equal to each other. As you can see, AB is much, much bigger than DE, but they are going to be proportional to one another. So what that means is that AB over DE equals BC over EF, which equals AC over DF. So as you can see, if I were to put any numbers here, like let's say I said that this length here is 10 and this is 5, that means we know that this triangle is twice as big as this triangle here. And that means that as soon as I said that this side here was 12, I would know right away that this one would have to be 6 because it's half. And in fact, my scale factor in this case is 10 to 5, which reduces to 2 over 1. So my scale factor for these two triangles would be 2 over 1. So now let's take a look at a problem here. It says determine whether the polygons are similar, and if so, write a similarity ratio and a similarity statement. So remember from the first slide, we noted that in order for polygons to be similar, all of their angles have to be congruent. And that's the first thing. And you'll notice that A is congruent to E, B is congruent to F, C is congruent to G, and D is congruent to H. So indeed, the angles work out for us. Now we need to take a look at the corresponding sides. And what I always like to do is start with the shorter side, so that would be a 6, and that'll correspond to this shorter side over here, which is the 4. So if I write it as a ratio, 6 over 4, and find out, does this equal, question mark, to the larger side 9 and the larger side 6? And so then I would write 9 over 6. So now I need to do a little bit of reducing here. And I find that 6 over 4 reduces to 3 over 2. 9 over 6 also reduces to 3 over 2. So indeed, they are proportional, which means that determine if the polygons are similar. My answer is yes, the polygons are indeed similar to one another. Now we need to write the similarity ratio. The similarity ratio is just simply what the one of the corresponding sides reduces down to. So then I would write my similarity ratio. I always like to abbreviate similarity ratio, I always like to abbreviate it as SR. That will equal 3 over 2. And now I'm going to write my similarity statement. And so what that will be is ABCD is similar to EFGH. And you'll notice that I have corresponded my A to my E, my B to my F, my C to my G, and my D to my H. I made sure to write it in the correct order. Okay, so it kind of goes without saying that if this was incorrect, so if these did not turn out to be congruent, my answer here would be no. And so if your answer is no, obviously you don't have to find the similarity ratio or write the similarity statement. Okay, so let's do one more example, and this is a real-life example. We want to find the length of the model car to the nearest tenth of a centimeter. The real car is 5 meters by 1.8 meters, and the model car is 6.3 centimeters, and we're trying to find this length here. So we're going to assume that these two are similar to each other, and so what we need to do is set up a ratio. And so we just simply set up, what I like to do is start with the smaller side. So I'm going to do 1.8. So that will be 1.8 over 6.3 equals, and so you'll notice I did the width over the width, and now I'm going to do the length over the length. And so that's going to be 5 over x. Now it's just a matter of cross multiplying. And my math finds that x is going to be 17.5, which means my answer for x up here is 17.5 centimeters. And there we have it. Thanks for watching.